Hello again. Now we are going to talk about solving linear inequalities. And inequalities are different than equations. Equations have an equal sign. Inequalities have symbols that we would use in the place of an equal sign, but mean not equal to, such as greater than or less than, greater than or equal to, less than or equal to, as well as not equal to. So these are all inequality symbols. And when we are dealing with inequality symbols, we will always need to write our answer or our solution in interval notation. And we've talked about that extensively in some previous videos. So if you need help, I can direct you to that video or you can send me an email. But interval notation, as I've mentioned before, is really important and it is not going away. So we need to get the hang of it early on. So first things first, let's talk about our addition and multiplication principles of inequality. So as long as we're given three numbers, A, B, and C, which are elements of the real number set, if we begin with some basic inequality, such as A less than B, then what we can say is it's completely legal to add the same real number value to both sides of the inequality. And that could be a variable as well, right? So we can say plus C to both sides of the inequality. And remember, addition is the same as subtraction. So that means we can add or subtract the same value to both sides of this inequality that we are dealing with. Now, as we begin to deal with the multiplication principle, we have two cases. We have case one. Case one says that C value is greater than or equal to 0. So that means it's positive or 0. Well, if it's positive or 0, we can multiply or divide by the same value on both sides of the inequality. So again, re-emphasizing that multiplication is the same but different operation as division. So multiplication is division by the reciprocal, or division is multiplication by the reciprocal. So case one deals with a positive number that we are multiplying by. Case two here says, well, if we start with an inequality and the value that we wish to multiply or divide by is less than 0. And less than 0 is our math way of saying negative. Well, what happens when we multiply by a negative on both sides of the equation? If we multiply or divide by a negative value, the inequality sign flips. So you'll notice that we started here with a less than, and now it is a greater than. So if we start with an inequality and we multiply or divide by a negative value, C is negative on both sides of the equation, then you must remember to flip that inequality. So you can multiply by a positive or a negative, but it's tricky, again, because we have to remember to just flip this inequality. So one thing, a strategy that I try to employ when I'm working on these problems is I try to avoid getting a negative coefficient in front of my x. And we'll look at an example where we do that. So sometimes when we start using our addition property of inequality to move terms to either sides of the inequality, we may move them in such a way that we avoid getting that negative coefficient in front of x, because remember, I'm going to eventually have to divide by that value, and dividing by that value, we just have to flip the sign. And we'll look at actually avoiding the negative and flipping the entire inequality. But again, most of these rules, you should be familiar with them. You've seen them before. It's just a big reminder, and this is a mistake that I often see looked over. So I'll notice that my students may have written on their paper, remember to flip the sign, and then they still forget to flip the sign when they're working through the problem. So let's look at this example. Here we have a linear inequality. We have one inequality symbol. It says we're going to treat it just like it's an equation. It's just that when we get to the end, we're going to need to remember to write our solution using interval notation. So I'll begin by simplifying on the left. I can combine like terms. That gives me 6x minus 5 is less than or equal. And then on the right, the 2 and the minus 8, that gives me negative 6 minus 6x. So now I've done my simplification, and it may look different. You may need to do more operations to simplify, but we'll go ahead and simplify first. Then I'll use my additive property of inequality. So I'm going to add my 6x to the left, and we'll notice as we add that 6x to both sides of the equation, I now have a positive coefficient right here in front of x. I have positive 12x. So 6 plus 6 gave me positive 12. So if I went to do that and move that to the left side and I noticed that it would give me a negative value, I may try moving to the other side of the equation to avoid having a negative coefficient here. That was what I was talking about. So as we continue to solve, I'll use my additive property again. I'll add 5 to both sides. That gives me 12x is less than or equal to negative 1. And then I'll divide on both sides by positive 12. And I'm dividing by a positive number, so I do not need to flip my inequality sign. So my final inequality here, my solution inequality, is x is less than or equal to negative 1/12. So less than or equal to negative 1/12 means we are shading to the left of negative 1/12. And my solution set is that x is in the interval from negative infinity to negative 1/12. And of course, we use a bracket at negative 1/12 because there is an equal to in here. If that had not had an equal to, we would use a parenthesis. Remember, you always use a parenthesis with infinity because infinity is not a number. It's not a finite quantity. You can't touch it. It doesn't exist. So when things you can't touch or when there's a value you can't touch, we would use a parenthesis here. So my solution set, what you would be writing on your paper or typing into the computer, is what I have boxed here. Again, I like to write x belongs in the set. You do not need to worry about doing that. Let's look at one more example with fraction. Here, we're going to solve another linear inequality, and we're going to write our solution in interval notation. The first thing you may notice, though, is that we have these fractions, and sometimes fractions are hard for students to deal with or they don't want to deal with them. So when we're dealing with an equation or an inequality with fractions, we'll look at the LCD of the denominator. And the LCD of 2, 3, and 4, the least common multiple we're going to have is 12. So 12 is the number that we're going to multiply each term by to clear the fractions. So we have 12 times 1/2 x minus 12 times 5/3 is less than 12 times 6/4 x. So you'll notice that each of these numbers now goes into 12. This was the smallest number that 2, 3, and 4 all divide into. So 2 goes into 12. That leaves me with 6 times 1x. Minus 3 goes into 12. I have 4 times 5. And then 4 goes into 12. I've got 3 times 6x. So all of these denominators reduce out. So looking at simplifying this, I have 6x minus 20 is less than 18x. Now, generally when we're solving inequalities, we try to move the variable over to the left. But what would happen in this situation if I said, let's subtract negative 18x? So what that would give me, I'd have negative 12x minus 20 is less than 0. So again, we're trying to get rid of the negative coefficient in front of x because eventually we have to divide by that number. And if I divide by a negative, dealing with an inequality, that inequality symbol will need to flip. So this is not how I'm going to choose to solve the problem. Instead, I'm going to subtract 6x from both sides. That gives me negative 20 is less than 12x. Now I'll divide by 12 on both sides. 12 divided by 12 cancels, and I have negative 20 twelfths, but I can reduce each of these by dividing by 4, so I have negative 5/3 is less than x. Now, negative 5/3 is less than x. That doesn't mean a lot to us when we're reading the problem, or we're reading the solution, I should say. So rather than remembering to flip the one inequality symbol, I prefer to have x on the wrong side, and then I flip the entire inequality. And if you think about this, the way you probably learned in grade school, you've got a little alligator, the alligator eats the bigger number. So when they switch sides, the alligator turns around and is facing the larger number. All right, so just keep that in mind. And that kind of helps us to avoid the error of forgetting to flip. I rather flip the whole thing rather than just one little piece in the middle. And if we look at writing this solution, this is x is greater than negative 5/3. Greater than, we use a parenthesis, greater than goes to the right. As we go to the right, we're approaching positive infinity. So my solution is that x is in the set from negative 5/3, not inclusive or open, to infinity. And then this is my solution for this inequality. So that is how we deal with inequalities. We solve inequalities the same way as we solve equations. We just need to remember to flip the either entire inequality, or when you're multiplying or dividing by a negative, to flip that single inequality symbol. So let me know if you have any questions, because I'm here to help.